Okay, so now timing diagrams. So if you are a very visual person, a timing diagram would be very helpful indeed. So how this works is that it's going to be a set, reset, and Q output here. This is an unknown state. I don't really know what's happening. I don't really care what's happening. It's unknown, all right? Don't be anxious. Certain unknowns are fine. This is one of those. So the starting is that it's 0, 0. So if we know 0, 0, I don't care. It just stays as it is. Yeah. So now I have the set going high. Reset stays low. If you remember your truth table for your SR latch, when S is 1, R is 0, the output will go 1. Now this value drops to 0. So there's a drop here. There's a change in the input signal. You'll be usually thinking, oh, there's a change in the input. There should be a change in the output, but not this case because 0, 0 means that the previous signal does not change. Let me bring you back up again. Bring you back up, up, up over here. 0, 0 does not change in the output. So if it doesn't change, means it was 1, it stays at 1. But now at time t2, the reset goes high. Okay, so now it's resetting back down to 0, so it goes back down to 0. Now the reset goes to 0 as well. There's a change in the input, but don't worry. 0, 0 means it stays at 0. So you must be very familiar in drawing the timing diagram. So you must know how to draw, you must understand how it works. Okay, so that's important as well. Okay, so let's take a look at review question 13.2. Okay, so this is review question 13.2. Can you describe the input conditions that will cause Q to change from 1 to 0? Can you? Can you? You should be able to tell me that if it's dropping from 1 to 0, it is being reset back down to 0. So your set is 0, your reset is 1 because you're resetting it back to 0. Sorry, I should have said, pause the video here, try the review questions yourself first, then play it and let's check the answers together. Okay, I might be wrong, you might be right, but do it yourself first. That's the important thing. Okay, next, what are the input conditions that will cause Q to remain in the same logic state? In order for the state to stay as the previous state, by now you should know that the set must be 0, the reset must also be 0. Okay, so these are the two input states. Okay, next, do you know how to draw the timing diagram? I don't have a ruler with me right now. I just have this little stencil. So forgive me if it's going to be a bit untidy, but you must use a ruler on your workbook, your textbook. Okay, so here we go. Set is going high. I don't know what the previous condition was, don't care. But if I know at this point set goes high, so I'm setting it to 1. So the output here must be high. It goes to 0, 0. So it stays at this state. Reset is going high. So I'm resetting it back to its original condition of 0. This is 0, 0. So it stays in this condition for however long 0, 0 stays. Reset back to 0, but in this case it's already at 0, so it stays at 0. 0, 0 means it stays at its original signal, but now there is a set. So I'm going to set it up high. 0, 0, it stays as high. Okay, so generally you must be very familiar with A. In order to draw this, you must be very familiar with the truth table of the SR latch, and then after that, understand the input signals, and from there be able to draw the output signal. Okay, cool. Okay, the next part, what is an SR latch used for? I'm going to start a new video on that. So stop the video. Well, the video is going to stop and kind of run through what you need to know for this. Be very familiar with it before watching the next one. Okay, what an SR latch is used for. All right, see you in the next video.